All right, so we tackle in this one here, which is the f of t. All right, when Miss giving you all the questions, she could either give you the graph plotted already, or she might give you the graph as a piecewise, and you have to plot it and then do the Fourier. Right? Anytime Miss give you the piecewise, what you need to pay attention to is these limits. Right? The number one rule or the number one advice I could give you, a period always ends at t. T is a period, right? T on 4, T on 3, 3T on 4, all those things are part of a period. So if I was to start at 0 and go a back quarter, I'll get T on 4. If I was to go up back again, I'll get T on 2. If I was to go up again, I'll get 3T on 4, and if I go up again, I'll get T. This is if Miss give it in terms of T. Right? If, like you say, Miss gave it in terms of pi, right? So 0, a period in terms of pi, right? It'll be 2 pi. So a half will be pi. And you have the 3 pi and you're going on your. So this t on 2 is equivalent to pi is a half. Right? And then you have your pi on 2. And you keep on going down because 90 by 4 is 360. So 0 pi on 2. And you get pi, and you get 3 pi on 2, which is like 270. And then you get 2 pi. Make sure you know these two forms. But all you have to remember, really, is that remember a period always ends at t. Everything before it is going to be subdivisions of the period itself. Because in Fourier, I'm just giving you periodic functions, which means that it will oscillate, not oscillate, it will repeat itself after every period. You have to remember that, it will repeat itself, right? It's not a non-periodic signal where it constantly changes, periodic. So after a period, it will just start over the same pattern. So in Fourier, you just need one period. You don't care about the rest. You need one period. It doesn't matter where on the signal it is. You just need one period. Yeah, that's how to remember that. Obviously, the easier period to use will be the one started from 0. Right, but don't get into the habit of only seeing it started from 0. You could start a period anyway. A period, graphically, is when the same pattern repeats itself. Right? And a period mathematically, right, is just one on the frequency. We gotta do that here. What you're looking at when you sketch the graph, you're just looking for the pattern, and wherever the pattern starts or where the pattern ends, or where it repeats itself again, that is the period. So hot up yourself too much about the graph itself. All right, so let me plot this graph. So let me just go back to here. So I plot it. So we have, so let's see how this one works. So they said from 0 to t on 2, which is half of t. That's how I think about it. So I just write t and minus t on both sides. So I know t on 2 will be half, and this here will be minus t on 2. And this is 0. So they're telling me from 0 to t on 2, so 0 is less than t on 2 and more than 0 is 8. So that is up here. So that is here, right? And then the other one that told you is that from minus t on 2 to 0 is minus 8. So from minus t to 0, so it's minus a, which is here. And that is it. So there's a graph plotted, right? So that's done. Second thing you need to do, right? You have 3 questions. I posted a video on this, so you can check it out, right? You need to ask yourself 2 questions. Is there a DC component? Is the function even or odd? Right? As the 2 questions you always have to ask yourself, right? So to know if a function even or odd, you can use the y-axis as a mirror, right? So for even, f of x is equal to f of minus x. What I mean by that is, like we said, this point here is f of x, right? Over a period is over a period. Okay, periodic. over a period, it must be symmetrical about the y-axis. So let's say I pick this f of x, right? So if I mirror this point across, this here will be f of minus x. So the laws for an even function is that f of x must be the same or point to the same y value as f of minus x. And we can clearly see that it does not point to the same value, that this pointing up here, which is not here, you're going quite down here. So therefore is not an even function. Yeah, if you go extend it over the period, because this might trick you, go straight until the pattern ends. So if I pick here and I mirror it, you get here. So it does obey the law because anything by zero is zero, so it doesn't change. So over the period, the function is not even. So let's try to see if it's odd. So for odd, f of x is equal to minus f of minus x over a period. So we're using the same point here. So that up here. So if we carry this across, you're clearly seeing that it's actually minus f of minus x. We're going down here, which is the negative of this here. So this here is a, this here is minus a. If you had picked any other points, you will notice that it does obey the odd function now. So therefore, over the period, make sure I'm extend straight across the period, because this might trick you up like that. Across the period is odd, it obeys the law, so therefore the function is odd. So we know that, and I'll tell you what it does do when it's odd. Second question we need to know is, does it have a DC component, right? Think about DC component as the area above the x-axis has to equal or has to be more than the area below over a period. So what I mean by that is I'll draw a sine wave so it is because everybody kind of familiar with that. So if you have a sine wave, right, the x-axis is where you're using to scale it. So the area above the x-axis must equal to the area below the x-axis. Once you do this, the areas will cancel each other. So you end up with a DC component which is A naught and 2 as 0 because it will cancel each other, right? This has no DC component. But if I was to do this, however, so it's still the x-axis. If I was to give you a graph like that, it's still periodic. There's t, right? It's still periodic. But you can clearly see that this area here is not equal to this area here. So when you actually do the integration, you will not get 0 because the area under the x-axis does not equal to the area over. So because of that, you will have a DC component. So if Miss give you some shape that you have the equation for, like she like to bring rectangles, triangles, squares, and that kind of stuff, you don't need to like do the integration part to do it. Because you can look at the graph and the first thing you could notice before you even you will hurt yourself if you do the A naught and 2 integration equation and you realize you get 0. That wastes of time. That means you could have look at the graph and see. So this graph here has a DC component. So when Miss asks you, all you need to say after you look at the graph, you say since the area above the x-axis is equal to the area under the x-axis across a period, of course, right? There is no DC component, right? So that is something to remember. Right, so back to our question here. So if we go back to it, now that we have the knowledge, a period in this case is don't think of it always from 0 to t. A period is when the pattern repeats itself. From where the pattern starts to where the pattern ends is a period. So the pattern starting here, let me change the color. Pattern starting here and the pattern ending here. As a pattern, and it will just repeat itself over and over. So at t here, the pattern will actually repeat itself over again, right? So it's starting here and then here. So that means the areas that we're looking at is this area here and this area here. Yeah, so we can clearly see that the area underneath here will equal to the area here. So it will not have a DC component. So what I mean by that is if we do the normal equation, this is the base and that the height. So a rectangle, so you call this one 1 and this one 2. So for 1 is t on 2 by a. So that would be a t on 2. And this area here, when you do it, it'll be minus t on 2 by minus a. So you end up with a t on 2, right? And you'll have to subtract both of them. Clearly, you could see that this area here is the same as this area. So when you subtract both of them, you will end up with 0. Yeah? When you do the integration, you'll end up with 0. So you don't need to do the integration, because you can clearly see it's symmetrical. The area above is the same as the area under. So you can just write a statement. Since the area above is the same as the area underneath, there is no DC component across the period. And just move on to the next thing you have to do. 3 marks, basically. Right? But if you notice it not well, you will have to do the integration to get A naught on 2. Okay, so that was that preamble. Okay, so now that we kind of understand odd and even and the DC component, we have to do the Fourier of it. So remember, so if you have an odd function, not even, and even goes with ek and cos. So if it is an odd function, ek will be equal to 0 for all k. Yeah? So, and if it's an even function is not odd. And odd does be bk and sine. So therefore, if it even, it have no bk to, so bk will equal to 0 for all k. Yeah, that's something to remember. It's literally 3 marks. So if you notice the function odd, do not go and calculate AK. And if you notice the function even, you don't need to calculate BK because you know it's gonna be 0 because the function even. Yeah, so that is 3 marks again right here. Just if you notice, like for some graphs, you may notice that when you do these two laws for even and odd, it doesn't fall into any. That means it is neither odd nor even. So when you see that now, you have to calculate AK and BK. All right, so I'm gonna write that in. So if it's neither odd nor even, you have to calculate AK. So AK and BK is not equal to 0. So that means you have to actually calculate AK and BK. Right? Neither of them is 0. All right, so let's go through. So that was that. Number 3 now. We'll do this as quickly as we can. So for number 3, so we know we don't need to get a naught, a DC component. We know it's 0 because the area above is equal to the area below the graph around a period. So we know the DC component is indeed 0. So we can skip that. Secondly, since the function is odd, AK is 0. So we just write since odd function AK is 0 for all k. I marked it. So the only thing we have to do in this question now is calculate BK. All right, so if you all didn't know, that's right here. So we have an equation for A naught and 2. You have an equation for AK, and you have an equation for BK. So A naught and 2 is 1 and t. Integral of t0 is just an arbitrary starting point to 0, t0 plus t. Obviously, you'll be doing it across the period of, you can say x of t, which is the graph itself, dt. So yeah, that's basically integration of the graph. This piece here is just the area under the graph. You don't need to integrate all the time. If you notice it fall under shapes that you memorize the area equation for, since standard 5, just use that equation and get the answer. Well, after it had to multiply by 1 and t after you do that. So this integration piece is just area. So if it's a shape, a triangle, half base by height, You do that, you get a t, and you plug it back into this equation, which is basically multiplied by 1 and t, and you get your answer. Quick proof. But you don't need to do this if you know. I have no DC component, but if you notice it did, you'll have to do this to get the actual value. The second one is AK. So the equation for AK is 2 on t integral t0 plus t. I'm not writing this, but it's just over the period of the graph, right? From where it starts to where it ends, right? X of t, so a, right? X of t cos 2 pi k f naught t dt, right? AK goes with cos all the time, right? And the last one, bk is 2 on t integral from t0 to t0 plus t of x of t sine bk always goes with sine 2 pi k f naught t dt, right? So these are the three equations you must know by the back of your hand when it comes to doing the graph for Fourier, right? And as I said, if you know the rules, yeah, most of the time, if much real wicked, she could bring a question where I calculate all three. But if she not, and you notice it, one, the A naught on two is zero, two, the even or odd, that means you either had to calculate AK or BK. That is the actual part you only had to do the integration for. Kind of help you out, but you have to be conscious of it. She wicked if she bring a question where I calculate all three. That is pressure. If she bring that, make sure and write the equations and probably do that question last, if I'm being honest with you. All right, so let's do this one. So in this case, our function out, so we have to calculate bk. So bk 2 on t. All right, so I'll need space for this for sure. So I don't need to write so big. I write small in the next line. So 2 on t integral from, so in this case, we're going from minus t on 2 to t on 2. That is one repetition of the graph. So if you look back, it starts at minus t on 2 and it ends at t on 2. So that will be the period you have to integrate, right? So x at t by sine 2 pi k f naught t dt. Okay, so I have to slow down. When you're doing this part of the integration, you have to move slowly and be very careful because you can make easy mistakes if you move too fast, right? So let's integrate it. So this is our piecewise integration. Remember the graph going from minus t on 2 to 0. That is minus a for x at t. And then from 0 to t on 2, the x at t will be a, right? So in this case, we have to split it up. So right, 2 on t, bar big brackets, and let's do it piece by piece. So the first piece of integration, you'll be integrating from minus t on 2 to 0, or minus a sine 2 pi k f naught t dt, right? And then we have to plus the next piece, which is going from 0 to t on 2 of a sine 2 pi k f naught t dt. Right, and you put that back, moving slow. So what I did there is that from the graph, I did from minus t on 2 to 0, and the x at t is always the graph itself. So in this case, the graph is one flat line at minus t, right? And then from 0 to t on 2, x at t was a. So I just integrated across the period. So you have this piece here, going real slow. So now we're slapping down the integration for each piece separately. So the integral of sine is cos. So the differential, if you differentiate sine, you get cos, and differential of cos is minus sine. So if I was to integrate sine, so the integral of sine theta will equal to minus cos theta. Yeah, so that's why it's important to know your integration rules. So I just remember the differential. So the differential of sine is cos. So if you was to integrate cos, you would have get back sine. And the differential of cos is minus sine. So if I was to integrate sine, the minus will have to go across, so I get minus cos. So that's something you need to remember, especially when you're doing these type of questions, right? Nice. So taking it slow. So if I integrate this, so when you're integrating it, you have to, in the bracket itself, there will be 1 over the differential of the bracket multiplied by the trig itself. There's like a trig. So this will be minus a. So the minus will cancel with the minus. So you will get from integrating the sign, so you end up with a plus, right? And then you have a divided by the differential of whatever inside here with respect to t. So that'll be 2 pi k f naught and cos of 2 pi k f naught t, right? And that between the bounds of minus t on 2 and 0. Yeah, that's moving very slow. But now we have to do the other piece. So we have plus, and we're doing this piece here now. So this here differential of sine is cos, differential of cos is minus sine, so it'll be minus cos. So it'll be minus e on 2 pi k f naught, and you have the cos 2 pi k f naught t, and that's going from 0 to t on 2, and you put all the break brackets. Okay, so we go in summary. So now we have to do the integration piece. So it'll be 2 on t. So as always, when you have to plug in 0 and minus t on 2 into this function here. So it'll be the top is b minus a. So f of b minus f of b. So f of b in this case is b and there's a. So f of b, if I was to plug t as 0, this whole thing will go to 0. So cos as 0 is 1, right? So we just end up with this piece here. Right? And then you have to plug minus t on 2 into this. So I'll do that part here. So it'll be, so remember is f of b minus, right? So this will be minus a on 2 pi k f naught cos 2 pi k f naught minus t on 2. Right? Remember, this entire thing is f. So f of b, when you plug 0, you get this, because cos of 0 is 1. And when you plug minus t on 2 into this, you end up with the, obviously is minus, so the minus will be there, a whatever it is, and you plug in the t. So that's that piece there. And we have to tackle this piece here. So when you plug in t on 2, so you just end up with minus e on 2 pi k f naught cos 2 pi k f naught t on 2, right? And then minus the f of b. Remember, it's f of b minus f of a. B is the top and A is the bottom, right? So something to remember. So that is B, nothing changed, the minus will stay. Then you have to minus something that is already a minus, so it'll be plus. And then when you plug 0 into it, just like before, this whole thing here will go to 0, and cos of 0 is 1. So you end up with A on 2 pi kf naught, right? And we close the bracket. So we go in now. So now I'm going to bring to your attention something very important when it comes to this step, right? A lot of people just forget it. So when it comes to this step, what you're looking for really, when you're doing these type of integration, you're looking for this. F naught by t is 1. Because 1 on the frequency is the period. And if you carry across F naught by t will just give you 1. So there's something to remember. So basically, everywhere you see a F naught by t is just 1. It just gonna just boil down to 1. So keep an eye in mind, as Mr. say, massage just a little bit, even though it's cringy. So you have 2 on t. right? You have A 2 pi k f naught. You have minus A on 2 pi k f naught cos. And you have this minus here. We have to get rid of this minus, right? But the thing about it is that cos a minus theta is just cos a theta. You could bring out the minus and it wouldn't change anything outside. Why? Because cos is an even function. F of minus x is equal to f of x, cos even. So you could fling out the minus and it wouldn't change anything. So therefore, I could basically just remove the minus. So it'd be 2 pi k f naught t on 2. And look at see, and the thing that we need, right? And then for the next piece, now we have minus a on 2 pi k f naught cos. And same thing here, 2 pi kf naught. This one have no minus. So that's be t on 2. And well, plus the a on 2 pi kf naught. And you put back the big bracket. So now what we could do is we can notice that this 2 will cancel with the 2. And this f naught by t. And this f naught by t will give me 1. Right? And the last thing we need to do, we can expand out the 2 on t to each term. Yeah, so let's do that piece by piece and I'm skipping any steps. So 2a, 2 pi k f naught by the t. Then you have minus 2a on 2 pi k f naught t. Then you have minus a or minus 2a on 2 pi k f naught t cos 2 pi k f naught t on 2 plus 2a on 2 pi k f naught t. Right, so obviously we see any SATA f naught t's and the twos that could cancel, so let me change the color. So we know the twos could cancel, obviously. Twos cancel, cancel, cancel. This will cancel with this, and this will cancel with this. And we know all the f naught by t's will give me 1. So all this will boil down to a on pi k minus a on pi k. I think I'm missing a cos. So I have a cos here. I forget to write it over, but I'm not gonna do it. So write it here. 2 pi, and this will be, so this the 2 here will cancel this here, that's end up with pi k. Right. Right, so this will be cos pi k. Right, and then this one here will be minus a on pi k cos of pi k, because it's going to go to 1, 2's cancel, and then this one here, 2's cancel, f naught by t is 1. So it'll be a on pi k. Right, so now we could bring things together finally. So f of t. So we have a pi k here, a pi k here, so that is what 2 a pi k's. And we have a minus a pi k cos, so that just be minus 2a pi k's cos of pi k. Right, with that said, that is the end. Right, so what you have to do now is to get the spectrum. So those are DC components, right? And you have the, well, just give it, but don't worry about that. Because that key will just boil down to something. And this piece here will give you a harmonic. So what you have to do now is, because it's odd, every time you go to an odd number, you'll actually get a value. But every time you go to even, you'll actually get the value. So let's see if we can do that here. So let's see. So k, we'll start with k is equal to 0. So when k is equal to 0, there's like your DC components. When you plug k in here, this going to go to 0, right? So basically, this whole thing here, null and void, because if you put k as 0 here, that's going to go to infinity. So we know it don't have a DC component already. So that in itself, you will, I guess, stunk. Yeah. So next we have 1. So one is 1, you get 1 here. So costs are pi, right? So if you remember, costs be like this. So there's 2 pi and I pi, right? So cos of pi is minus 1, right? So then minus 1 here and 1 here. So when you plug 1 into this, you get minus 1 here. So you end up with 2a pi plus 2a pi. So you end up with 4a on pi. No, so we know it on. I mean, that's ready to do the single first, not to compute because we're not going half. All right, and then for 2 now, for 2, you get 2 pi here. Well, look at it, 2 pi, when you plug it in here, 2 pi is 1. So therefore, you'll end up with 1 here, and obviously 2, so you end up with this. Watch it. So you end up with 2a, k is 2, so it'll be 2 pi. And because it's 1, the sign are going to change. So you end up with minus 2a on 2 pi. And what that going to give you? Going to give you 0. Why? Because it's an odd function. Yeah, so it will only give you a value when it's odd, right? So when you go to 3 now, obviously if you're seeing for 3, it wouldn't give you 0, it will actually give you a value. So let's say we'll give you when I give you 3. So it'll be 2a on 3 pi. Let me see, cos, yeah, usually calculator. So that'll basically just be a repeat. So it'll be minus 1, so it'll be plus 2a on 3 pi. So it'll be 4a on 3 pi. All right, and obviously we know 4, we get nothing. And then 5, looking at the pattern, the, the bottom just gonna increase by 2, so you're gonna put 4a on 5 pi, and the pattern is going to continue, right? This is a single-sided spectrum. If you want to the double-sided, you know, you have a half. These, right, and it has no phase, as it has no phase. Well, I like has a phase, but I'm not going to show you that. But for now, this is where you will end, right? Just getting the BK. Once you do the integration, you get this, to get the spectrum, you just plug in the values at k, and because we know it is a solely odd function, it will only give my magnitude when the values are k odd. If it was an even function, it will only give my values when it was even, like 2, 4, 6, 7. If it was odd and even, or neither odd nor even, that means at every number, you will get a magnitude value. Right? So the next thing you need to remember. So to get the phase, you'll notice that this have nothing with phase. And you might be saying, but how you gonna plot the phase? So it have a nice equation that I just use to get theta k, right? Is minus tan inverse of bk on ak. Right? But watch this, right? Watch it very carefully. In this question here, what we actually calculate, we calculate bk, because it was odd, and ak is 0, right? So watch how you can do this. Anytime you have this, it's have something called a Cartesian plane. And watch how we can actually get what the angle is, right? We know AK was 0. So AK is the horizontal and BK is the vertical, right? AK was 0, right? 0. So that means it's staying here. But BK, I had values for BK. So obviously the values of BK, it will stay on the y-axis. So therefore, if I want to know the angle, right, we always measure angle from the positive real axis. Yeah, so therefore the angle will always be 90 degrees all the time. Yeah, so therefore we clearly see in that for the phase spectrum, it will be constant across all harmonics. The phase will be constant across all harmonics. Why? Because AK was 0 and BK was a value. If you plug that in a calculator, that'll be tan inverse of infinity. But you don't do that. Just plot the arc diagram and you can clearly see, hey, the values of BK change and that is okay. But AK not. So therefore the value will always be read from the positive real axis. In this case, it will always be 90. So if I also plot the phase of this across all the odd harmonics. So 1, 3, 5, that's a single side. We end up with a constant. So minus 90, minus 90, minus 90. It would just be constant, it wouldn't change. Yeah, that's because AK was 0. If it was an even function, even, right? If it even, that means BK is 0 and AK is a value. So if I look at the Cartesian plane now, watch it. So if it's even, BK is 0, so therefore it's not going up. But again, values are AK. Yes, that means it's staying on the x-axis. So therefore, the angle from the positive real axis to the positive real axis is 0. So therefore, if you was plotting the phase spectrum for it, all the values would just be 0 for the phase. Right? And then for our odd function, all the phases are minus 90 because this equation here given a theta k, and you know, okay, in this case, AK was 0, BK was a value. Obviously, I can't plug infinity in my calculator. Go on the Cartesian plane, I plug it in. Hey, BK is no AK, so therefore all the angles will be 90. So again, that puts your minus 90. Right? And then for even, same idea. Plug it in. You could plug tan inverse of 0 in the calculator. So try that and see. But then if it even, that means the BK was 0. So again, with 0 divided by number, and you end up with the value. Right? With that said, the integration for even, similar. It just integrating costs instead of sign, and same general equation. All right, but with that said, that was the end of the question for the spectrum. If you want to double-sided, obviously, you know, you have to cause it in this form, which is similar to what we know. You could use this cost to get in the exponential form, like what you was doing, right? Or you could just plot the single and then half whole to get the double, which is why I will do, just to save time. Because this question does take long to do, especially if you're not too strong in with your integration and stuff. But just take your time and practice it, and it will come to you eventually. All right, so let's stop your code.